So the recording has started. So what we're going to do today really fast is we're going to go over, although I got rid of it because I had to exit out, but we're going to just do the definitions really fast. So that'll be too big. So let's go ahead and start with, and I know this is, repetitive, but that's sort of the point. So link, elements, joint. So I'm going to put J1 and J2. Binary. I really need a stylus or something, but you guys can go ahead and start answering. Type into the chat if you want. And then in element. So definitions for these. So let's start with the first one. Link is a what? General shape. Agreed. So I'm going to put shape. Alright, element. What is that? Element is a modification. So some sort of modification we had to make. Yeah. Remind me to spring for the text tool. I'll do that after this. What is a J1 type joint? There are 3 of them. Everything besides a roll slip, so I guess that answers it. So which ones are those, Jackson? So let's do revolute. I agree with that. Sliding. And rolling. And then since he said it, this last one is a roll slip. Roll slip. Alright. And then we have binary, ternary, and in element. Someone besides Jackson, answer what that is. What are those what are those things? Binary, 2 elements, correct. A 2 element what though? Link, correct. Okay, yeah, man, this is real bad. 2 element link. Ternary is 3 elements. And in element is, as it says, more than 3. So 3 plus n, essentially, like whatever it is. 3 plus 1 plus 2 plus whatever is an n element. Alright, so those are the definitions that we have in the class so far, right? That is all of them. This is all we've done. So I'm going to put those in a nice little box. Those are all the definitions. So, really quickly, this is something we didn't look at last time, but this right here is an example of what these look like. So a binary link, very quickly, just something like this, right? You have 1 modification, 2 modifications get you a binary. This right here, you have a hole here, and you have it sliding right here, so it's 2 again. And then, similarly, these are ternary links. 1 here, 1 here, 1 here. That makes 3, and then you have 1 here, and then this slider was cut out. Does everybody see how that works out? Like how you get 2 and 3 from those? Was there anything else I wanted to look at before we moved on? So no. So what we're going to do really quick, I know we looked at this one on the first day, but we didn't do any of the, we didn't actually do the question. So you guys are going to tell me, once again, the number of links, elements, joints, degrees of freedom. Oh, that was another definition I forgot. We're just going to put D, O, F. Degrees of freedom. Degrees of freedom is just essentially the directions of movement that a mechanism is allowed. So it's like I don't know how to write that shorthand, but essentially allowed movement. Let's go with that. All right, and now this is the extra special bonus part because we did talk about it very shortly. How many degrees of freedom does a J1 remove from a mechanism? It removes 2, correct, Rosendo. And you can see that reflected in the equation for degrees of freedom, that there is a 2 multiplier times your 1 on the inside. And then, ternary removes 1. So this J2 removes 1 degree of freedom, J1 removes 2. So very good. All right, so for this one, I'm going to go ahead and put it over here. So I'm going to just put down L, E, J1, J2, and DOF. And then I'll do binary and ternary. So all I want is the numbers for all of these. So links, how many? Obviously they're written on the question. I have eyes too, but that should get you off to a good start, hopefully. So I guess I could call on somebody. Hopefully they're here. Hector, are you here? How many links are in this question? This one right here. You say 7. Why do you say 7? So the correct answer is definitely 6, right? So definitely 6. There is no ground for this one. It's just kind of floating out in space. I guess you could consider this one to be, it looks like it's grounded because it's showing like lines across it. But yes, there are 6 on this one. And this one is numbered. In other questions, they will not be. Most of the time, they won't be numbered, which is the whole point of the question. So yes, we have 6 here. Now, let's go down to, let's skip elements for now. Let's go to J1 and J2. So how many J1 joints do we have? Which are, as we said over here, revolute, sliding, and rolling contact. So how many of those do we have for this question? Let's go with, Mohammed. Since you're already typing, go ahead. Think 14. So we have 1 here, 1 here, 1 here, 1 here, 1 here, 1 here, 1 here. Anybody want to take a shot again? 7 should be the answer. Yeah. Oh, I meant the joints. So we're skipping the elements right now because that one's it's based on the joints a little bit, so we're going to figure that out first. So this right here was 7. because you will find that if all of your if all your links are binary, then you can just multiply the links by 2 and get the elements. But for this one, we're about to go to that. How many J2 do we have, by the way? Just before we move on to that, there's like something you can figure out. It's like a little pattern, I guess. That's what people figured out for this. Anybody for J2s? How many? 0 is the correct answer because there are no roll slips in here anywhere. These are all revolute joints. Alright, so now this right here is we're going to go to binary and ternary. And the reason why we're doing it this way is because, like I said, the elements are based off of how many links there are and the types of joints there are. So I'll explain that in a second. But binary, so let's count them out first. Let's go through this. So we're going to start with link 1. How many is this one? Is this a binary or ternary link? This one is a ternary link, so I'm going to put a dash mark there. So we have 1. Let's go to 2. Binary. 3, binary. 4, is ternary, agreed. 5, binary. And 6, also binary. So, this right here is how many we have. We had and this is how you check at the end. You have 6 links, and you had 6 binary or ternary, so they add up, right? So we have 4 binary and 2 ternary, which are this one and this one are the ternaries. All right. So the reason why we did this sort of backwards is because if you know how many binary and ternary are, you can actually do this one a little easier because you have the number of links, right? And you have the number of elements on it. So it does, so this is what people did in other classes that they found out. They're like, oh, well, if I have 4 links and all of them are binary, then the number of elements is, right? This is just 2 times 4, right? So that is essentially what they started to find out. But for this one, it doesn't work out that way because we have ternary links, right? So the way that I always do it is I don't like to rely on that, like, I don't like to rely on going, oh, well, it's 2 times this or get me the answer. I like to actually do it out because making an assumption like that, or maybe you just misread the question, the tried and tested way of doing it is to just go through here and count them out. And that's what I always do. So I'm going to start at this joint right here for elements. And then we're going to go clockwise around. So I count 2 for each one because you needed 2 for this. So what I would do is I'd go 1, 2 here. Right here would be 3 and 4. This would be 5 and 6. 7 and 8. 9 and 10. 11 and 12 and 13 and 14. So 14 is what it looks like. So let me see if that is correct. I'm fairly certain it is, though. Yes, so there are 14 elements. And so basically what that one down there just said is that there are no coinciding revolute joints. So if there's no coinciding revolute joints, you know that they are all, it's basically 2 times that. But like I said, I don't like to do it. I like to just go through and I like to just count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Because I know that for each one of these revolutes, 2 elements had to exist. So I've always found to do it better that way. Leads for less error. And I suggest you do the same. Alright, so this one is correct. As you can see, we have binary links were 2, 3, 5, and 6, 14 elements, 7 J1s, and 6 links. So we were right on all accounts. Perfect. So let me get rid of this before we move down. All right. And so this will be the next one that we're going to do. We're going to do this one. So I'm going to do the exact same thing. I'm going to draw it out. So what I want you guys to do is, can you can enter down in the chat, right? Let me see. No, you can't, actually. I was trying to, can you, no. I was trying to get it to where you could enter down. So you could just type it all out at once. But if you guys type it out at once, this is how you should do it. So links equals, X, Y, Z, then E equals. Type it out like that, each one of you, and I'm going to give you guys about 10 minutes. So just type out like all the stuff that I put down. So I'll do it again. L, E, J1, J2. And do be careful though, this one is a little trickier because we do have sliders. So you do have to count things differently. So L, E, J1, J2, B, T. Oh, I forgot to do degrees of freedom for the last one, didn't I? Degrees of freedom is 1, though. As long as you plug in the number of J1s and stuff, you'll get it, which right here is, they did it in front of us. So, my fault. So L, E, J1, J2, B, T. Okay, I think that's everything. So they did leave some hints on here. They are writing this right here. So do be sure to take that into account whenever you do this. Yeah, I can't go any further down unless I'd have to show you the answer. But everybody look away for a second. Well, that didn't go well. It's like a government document. That's where the aliens are. So like I said, write it out, everything in one post, and then put it down across the message. I want to see everyone at least try it, because this first exam is a gimme if you've been even staying awake during it. So, is everyone typing it in? Once they get it right. I mean, hopefully you guys get it first, then type it in. Stand up for a second. So Salim, put them all in one post. So do L equals 3, comma, E equals whatever, comma, all in one post. But I would revisit that links one. Definitely revisit it. gonna give you guys another like 5 minutes before we move on. Can degrees of freedom be negative? Degrees of freedom cannot be negative. I am fairly certain. So Sean has an answer down. We got a wide range of answers here today. Wide range of answers. So, I'm going to give another minute till 1:30, and then we will go ahead and count it out. A lot of different answers, though. All right, so I'm going to go ahead and do the question. Like I said, we have a very wide range of answers, but don't worry about it. If you got it wrong, the important point thing is to figure out why. Alright, so here we're going to start with links. And so links are shapes. And now I think I see why someone might get, for example, 3 or 4, is because you guys probably did not count these right here. I'm going to guess that is the reason, right? Yeah. So this right here, this is why these drawings can be tricky, is that, so these are like cables. And cables are shapes, they're just very small ones. And so these are lines, right? But I mean, this is where it can get tricky. So essentially so shapes is just the like general thing, but if you see something like this, you have to count any sort of like, so think of links as shapes, but also if you think of the actual definition of like what a link is, it's just linking, it's like basically it's a point connecting here to here. So it is a shape, and so I would definitely, if you see these things, these like cables, which you don't see them that often, but these do count. So I'm going to go ahead and start counting them off. So we have 1 link, which is the ground, 2, 3, 4, 5, and 6. You do not count the ground again. So that means we have 6 links. So whoever got that is correct. Let me go ahead and get rid of this crap. Alright. Now, let's do elements. So this one is probably the trickiest one. So elements. So what you have to do is, this is the same thing I do on the last one, is that I count all the elements at their spots. So for example, we have 1 and 2 here, right? 3 and 4 here. Then we have 5, 6. So this is 1, 2 had to be drilled in there, and I think 7 here. I'll have to see if that's right in a second. I need to redraw that. That's really bad. It's hard to see. So I'm going to do 5, 6, 7. And then we have 8, 9 right here. And one of these is redundant, I think, but I'll make sure. And then this is 10, 11, and this is 13, 14. So I think that is the right answer. I will check here in just a second, because like I said, I didn't look at this beforehand, so yeah, sue me. Let me look. So elements, there are 13. So I was off by 1. So where is the one that I was off at? Oh, I know where I was off. It's this one. Oh, did I skip 12? So I was right then. Oh, that's funny. Yeah, my bad. 8, 9. So 10. So wait a minute. 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh my god, I'm so dumb. So yes, I was right then, except that I can't count. Just goes to show you though, if I don't have enough toes and fingers, because I'm wearing shoes, can't count. So, this is where we're at. So 13 was the correct answer. And the reason why it wasn't higher was because you do not have to count this wall again. One of them is redundant. So how many people got that? Why are the 2 at shape 2 and shape 6 at? Oh, okay. Yeah. So right here. So if we take this block out and remove it, we had to drill a hole, right? So we had to drill a hole through this block. So I'm going to start with this block. We had to drill a hole through this block, right? And then for this wire, I assume this is why the wires one is confusing. We had to add a tip that went around the pin, right? To fill in on this hole, right? So that was 2 modifications. So there's one here, another one on that point, and then there's 1, 2 here because we had to prepare the surface to come into contact with the ground. So that is that point. 5, 6, 7 are 3 links each with 1 mod. Let me see. Not quite. So I'm going to explain 5, 6, and 7. So one sec. Let me do, and that's sort of the same one as this one. So let's draw this out. So we have this, which is the block coming down. Would you guys agree that we had to modify the block by adding a hole to it? Is that okay? So we'll mark that as 1. Then we had to do the same thing we did with the other wire, right? Would you say that's another one? Right? You have to, okay, so 2. And then the other wire came up as well. At least that's how I see it. 3. But although I think, one sec, I might have miscounted that. Now that I look at it again, give me a second. There is no coinciding. We have 2 by 5 plus 3. There's 1 coinciding revolute joint. Yeah, which is this one right here. Okay, yeah, I mean, it's counted, right? So, yeah, okay. Maybe I thought I did it wrong for a second. So the reason why we can assume that is simply because, like, so if we did this, right, if we actually made this thing, you know, this block, and, you know, put these cables on it, how would the cables stay there? They have to be attached to something, right? We can assume these are, like, sort of rigid in some way, right? Like, as these things slide. So as this thing pulls down, these go further this way, right? And so they have a finite length, and so that means they have to be attached. Because if this pulled down and these just fell off, then that doesn't really make sense, does it? So we have to assume that they are pinned in some way. Yeah, they could have been tied through the hole, but then that also is a modification we had to make, right? I mean, yeah, I mean, I guess it could be tied. I mean, shit, fair enough. But yeah, essentially some modification had to be made. They're not just floating there and it's still rigid, right? They have to, something had to be done to get them to stay rigid as you pull them apart. At least that's the best way I can explain it. But just to show you guys, though, this is... I'm actually going to pull them up right now because I think this is something that you guys would really like. Let me see. Did I get rid of that? I wonder if I got rid of it. Yeah, come on. Here it is. Okay. I figured I would show you this while we were chilling here, but I'll just wait for it to pull up. So that means we have 13 here. Until it pulls up, I'll just wait. Alright, so let's do J1s and J2s. So how many are there? I think a lot of you guys said there are 7 J1s, so I would assume there's... So I'm going to get rid of this and I'll count them up. So 7 J1s. So we have 1 sliding, right? 2 revolute, 3 here, 4 for the sliding, I would assume, 5 for another slider. So you guys are probably wondering why we... let me see, actually, let me make sure that's the right one. So there are 7 J1s. Yeah, it's because there's another slider over here. So you guys are probably wondering, why is it that we skip counting? We don't count it for links, but we don't count it twice for elements, but we count it twice for J1 types, right? I feel like that's probably coming. So the reason why for J1 for like link type or joint types is that it's important, because if you don't do that, oh wait, it says it's a second is a redundant joint. So what is it then? So this is 1 for the ground, 2 for here. Oh, now I know. Never mind, I'm stupid. I forgot that this one was overlapping. Yeah, that's my fault. This is 3. This is 4, 5, 6, and 7. Yeah, I forgot it was overlapping for a second. So do you guys remember that there was part of the notes up here that the number of links is n, and the number of pairs, so joints, is n-1. So we have 3 links connecting, and it's n-1 gets you 2 on that point. Yeah, that was my mistake. Yeah, so that's another thing. You have to remember to take that into account. So 1, 2, 3 is the slider, 4, 5 for this point, 6, and 7. And as it says, 1 is redundant, so we don't need one of these points. I only counted one of them. So that gives us 7 J1s. And the reason why we have no J2s is that none of these are roll slips. And roll slips are basically just they're basically just like slider and pins. So if you see something like that, it's usually a roll slip. So we'll just put down 0 for this. And now binary and ternary. So how many, what did we say for this one? So we have, someone said we have 7 binary. Sean says we have 5 binary, 0 ternary. So let's go with link 1. So this is going to be the confusing one. So let's start with link 1. So how many elements does link 1 have? This is a confusing one, so do take a second to think about this. How many modifications does link 1 have? And remember, link 1 is the ground. It is the ground here, and it is the ground up here. So carefully think about your answer. Three. So Rosendo says 3, right? Jackson says 4. And the difference between you two is, I think, so you counted 1 here, 2 here, and 4 here. Or yeah, you guys counted. So essentially the difference between you two is that you guys counted, you didn't count one of these. And I actually, let me see which one it is, because I'm fairly certain that it is. What was I looking for? Oh, binary and ternary. Yeah. So it says that all 6 links are binary. And the reason why all 6 links are binary is that, once again, some of these are redundant. So we have 1 here, and it basically, they count it for both sides. So 1 here and 1 here, right? And then 2 here attached to this. So that's the trick here. So you essentially had to get rid of, you had to take away 2 of them. Now, really quickly, there would be more if, let's say, for example, this 6 was on its own going up. So, like, let's say 6, instead of coming down here, was, like, up against another wall over here, then there would be another one. But because they share the same ground, you only count it as one. At least that's the way this question looks. Although something tells me that they didn't. So real quick, just to throw this out there, is that this book sometimes has mistakes in it, or there's a lot of there's like some vague stuff, and so this one might be one of those times, because I'll have to look at it a little bit further, but something tells me that that is not basically there's something vague here that isn't explained, but they say that all are binary, which I do agree with that, because all these are definitely binary. So this block is binary, this cable is binary, this one definitely binary because it only has one here, one in the middle. This is binary, and this is binary again. The only one that I would consider contesting is the ground. I actually would contest that the ground is not binary, but I'd have to argue with the guy who made the book. Yeah. Because, so this is where my contesting, so Jackson, I would say that you are actually right. This would be my opinion, because you would count one here, right? One here. And what they did is this wasn't treated as the ground. This wasn't treated as the ground, I don't believe. And I would count this over here and this over here as well. So that would put it at 4. But for some reason, he did not for this one. So that's an argument I'd have to have with him. But real quick, just so you know, if we're going to straighten out what I think we should turn. So, like, for example, there are some times in here that he expects something that I do not. And I'm going to tell you what I expect specifically on every exam. And so this stuff, this like vague stuff that's like explained in the book but not really, you will never be punished for something like that. And you will also never be punished for something that I can't explain because of how vague the book can be sometimes. You will only ever be expected to do things that I have told you to do. So, like I said, I would contest that that is actually wrong, but I can't really talk to the guy right now, so I'm going to go ahead and just assume that that is 6 binary links and 0 ternary. And then degrees of freedom, did somebody do this equation? We have Sean that said degrees of freedom were 3. So this will be, what? So 6 times, oh no, it's 3. 3 times 6 minus 1 minus 2 times 7, right? Minus 1 times 0. Is that the correct one? I think that's the equation. So it's 3 times our number of links minus 1 minus 2 times our number of J1s. Number of J1s, which is here. And then our 1 times our number of J2s, which is 0. Which gets you your total of 1 degree of freedom. Oh, and real quick, what I was going to show you was, since it did load, I will pull it up. So, for later questions, actually, well, for one that you've already seen at least, let me see if it pops up, because this will be pretty interesting to you guys, I hope. Let me get rid of this. Maybe it will load. Hopefully it does, because I spent a lot of time on this. So this will be a problem that you will see probably later in the class. You definitely will see something like that later in the class. And so what I've done is a lot of these mechanisms that we do, I've made them in, what is this, Autodesk. And since I've made it in Autodesk, you can, so later in this class, you're going to have to understand how things move. And so I've sort of done it for you. Right? And there's another, so like this one's one that you've actually already seen. And so basically the reason why I thought of this was because Jackson was talking about how things are attached and how can you tell if something's attached to, other things. So this is sort of what I've done. So you guys have already seen this one, right? This one is one that we did just the other day. Right? And I'm going to post all these online so you guys can look at them. Autodesk is free for everyone. So you guys can get on here. And if you need to draw something to have it make more sense, you are more than welcome to do so. Because there was a question, so there was a student last semester who had a real problem with assumptions. And what I mean by that is, so real quick, what would you guys, if you looked at this right here, this is going to be a fun one. This is the, let me see if I can find it exactly, because we actually already looked at it. Anyway, if you guys looked at this drawing right here, what would you say if I drew a line, right? You guys probably understand that these two blocks can never leave this line, right? This line that I've drawn across the middle. Would you agree with that? Because they are grounded, correct? Does that make sense? Okay. So there was a student last semester, and by the way, so this is the next thing, is that this was his problem with me, is that if I drew this line across the middle, what did I just make? Essentially, I've just made a triangle, right, that you can find all the angles to pretty easily, right? If you knew one, you could probably know or if you knew two of them, you could know the third one, right? So his problem with me is that he said you cannot assume any one of these angles. And so on that drawing, let me see if I can, that specific one that we were looking at. So this one right here, this is the one that me and him argued about for like 20 minutes. He said that this right here, he said you could not assume that this is a 90-degree angle at any time. So his problem was that he said that this line, so like the ground is flat. He said, how do you know it's flat? And he basically argued to the death with me for like multiple class periods and said that you cannot assume that this is a 90-degree angle. And yeah, I know what you're probably going to say here. He had I don't know if he was just being an asshole, I could not tell. But he's right, but he's also missing the point. he's missing the point. And so for this class, assumptions do need to be made from time to time, and you guys will have to make them. So for example, on this question, I want you guys to assume that is 90-degree angle right there. He could not assume that and said I was just like horribly wrong, and that if you assumed that the ground was flat in the real world, you would get fired. So yeah, I didn't know what to tell him, so I just stopped arguing with him. So do not have those problems here. you shouldn't at least just make assumptions that look like that. If they look flat, they are flat. Like, for example, like this. You can tell this is grounded, it's flat. So real quick, let me see what I needed to do before we get off. So tomorrow, what we're going to do is we are going to probably do a more advanced question, which will be something like probably like one of these. Actually, we'll probably do something like that. This one right here looks fun. So we'll do an advanced question, and then as soon as we're done with the advanced question, we will adjourn, unless you have questions. And then Friday, we will do a little review, of all the stuff that we've talked about, and then I will move on to chapter 2 before your exam. So we are done for today, but do be prepared to come in and answer a question like this tomorrow, or like that, something like that. And if something didn't click today, this is in the book. I'm just reading from it, so you guys can go and look at this question right here. And if you have any other questions, you guys can send me a message right now. But the class is over for today.